In this video, we show the steps for assembling a motorized swivel for in vivo recordings. You will need some 3D printed parts which are available for download at the NIH 3D Print Exchange at the link below. You will also need to assemble two PCBs with some surface mount components. All the design files, bill of materials, and component placement files are available at the Open Science Framework through the link below. If tools for assembling surface mount components are not available, you can place a turnkey order at any PCB assembly company and let them manufacture and populate the boards. Let's get started. For the motor assembly, position the magnetic encoder PCB on the back of the motor. Solder one of the motor pins first with just enough solder to keep it in place. Then solder the other pin. Come back to the first one and finish soldering. Do not overheat the contacts to avoid damage to the motor. Cut the slip ring wires to 4 inches on the rotor side and 2 inches on the stator side. Isolate and twist pair the pink and red wires on the rotor side. These will carry the LVDS signal. Repeat on the stator side. To compensate for shrinking, adjust the length of the other wires on both ends. With a wire stripper, remove half an inch of insulation from all wires. From the rotor side, insert all the wires through the slip ring hole on the frame. Align the slip ring to the frame to allow for the motor cable to fit in between the two wire bundles on the stator. Secure slip ring to frame with M2.6 screws and nuts. Insert all the wires on the rotor side into the rotor pulley. Next, cut the 9-pin JST cables, leaving about an inch of wire from the connector. Follow this pin out to solder each wire to the slip ring. In our case, we crimp directly the JST connectors to the slip ring, although this is not required. To avoid damage on the connectors, apply non-conductive epoxy around the Omnetics connector. Mix the two parts and apply both on the stator PCB and on the rotor PCB. Depending on the accuracy of the 3D printer, it may be necessary to increase the inner diameter of screw holes with the appropriate drill bit. Secure the crossed roller bearing on the stator using the 6 M3 screws and nuts. Attach the motor to the motor frame with the M1.6 by 3 mm screws. Push the motor pulley through the motor shaft and align with the slip ring pulley. If necessary, add a drop of epoxy or superglue to keep in place. Mount the timing belt, check the pulley alignment, and make sure there is just enough tension to prevent the timing belt from slipping. Depending on the strength of the chosen material, it may be necessary to loop some tape around motor and slip ring to prevent motor frame from warping over time. Check the tension on the timing belt. Using pliers, pass the two connectors on the rotor side through the crossed roller bearing. With the remaining M3 screws, mount the rotor to the cross roller bearing. Connect the 6-pin JST cable to the back of the motor. Aligning the rotor pulley with the rotor, push the motor assembly through. Secure the motor assembly to the stator with two M1.6 by 5 mm screws. Verify proper pulley alignment by slowly turning the rotor and checking motor shaft rotation. Mount the two ball bearings and the magnet holder on the 2 mm rod and slide through the shaft holder. Use epoxy if necessary. Attach to the bottom lid. Crimp the alligator clip to the end of the 2 mm rod and secure with epoxy. Use M1.6 nuts to lock assembly to bottom lid. Mount the rotor PCB connector side closer to the edge. Ensure a 1 mm gap between Hall sensor and magnet. Mount the stator PCB connector side closer to the edge. Connect the cables to stator and rotor PCB. Rotate bottom lid until aligned with rotor, and close lid with screws. Repeat for top lid.